Hey guys, Mr. Jorgens here. Section 2.3, Linear Inequalities is going to be a part 1. We'll do our part 2 tomorrow. It's going to be very similar to section 2.2, which was solving one-step linear inequalities where you had to undo adding and subtracting. Except today we're going to, instead of undo adding, subtracting, we're going to undo multiplying and dividing. So one-step linear inequalities where we have to undo multiplication or division. Just a couple examples. We're going to have a couple quick questions in there for you to answer as well, so make sure you're paying attention and writing stuff down in your notebook. All right, there's our first question, example 1. Now, before we go about answering example 1, what I want you to do is think about that symbol on the left-hand side. This one right here. We've had some issues, people saying it's a fraction and just guessing whether it's add, subtract, multiply, or divide. We always want to think of it as add, subtract, multiply, or divide, because then we'll know what the inverse is so we can undo it. So answer that question. Is that symbol right there talking about addition, subtraction, multiplication, or division? All right, good. Hopefully you got that's division, right? So as soon as we know that it's division, we can go about undoing it, right? So if that's divide by 8, I can undo it by multiplying by 8 off of both sides, because the opposite of divide 8 is multiply 8, right? So when I do that, I can undo my divide 8 by multiply 8, and I'm left with x on the left-hand side. And then negative 5 times 8 is going to make a negative 40 on the right. So my solution set is going to be x is greater than negative 40. When I go to draw this on my graph, I'm going to center it at my key number just like I did in section 2.2 and 2.1. So it's centered at negative 40. I'm going to draw a couple numbers in each direction. In this case, two numbers that are just bigger than negative 40 are negative 39 and negative 38. In this case, those would work for x's because I want numbers that are bigger than negative 40. Two numbers that are a little smaller are negative 41 and negative 42. In this case, 40 does not work. And since 40 does not work, I'm going to draw an open circle. Again, a closed circle is going to be for greater than or equal to or less than or equal to. Open circle for greater than or less than. And I'm going to draw my arrow toward the numbers that work, like negative 39 and negative 38. Here's our second example. 3x less than or equal to negative 24. Now this 3x here on the left-hand side is either going to, there's an invisible operation there. Either it's 3 plus x, 3 subtract x, 3 multiply x, or 3 divide x. Tell me in the answer option, select the answer that's the correct operation here for 3x. Good. Hopefully you wrote down that it was 3 multiply x. So 3 multiply x, there's an invisible multiplication dot there. So when we go to undo the 3, we're going to have to undo it by dividing, right? Because the opposite of multiplying is dividing by 3. So I'm going to divide 3 to both sides to undo that multiply 3. And when I do that, I get x on the left is less than or equal to, and then negative 24 divided by 3, and negative divided by a positive is a negative from our multiplication triangle. And 24 divided by 3 makes 8. So x is then less than or equal to negative 8. When I go to draw my solution set, I'm going to center at our key number, negative 8. Two numbers that are bigger than negative 8 would be negative 7 and negative 6. Two numbers that are smaller would be negative 9 and negative 10. I'm going to put a closed circle at negative 8, and it's less than or equal to, so I'm going to draw my arrow to the left. So that would be a graph that represents our solution set here. All right, go ahead and try to solve this one on your own. 4x is greater than 36. All right, hopefully you realized here that I was undoing a multiply 4 by dividing 4 to both sides. When I divide 36 divide 4, I get 9. Multiply 4 and divide 4, they're inverses, so they cancel, and I'm just left with x on the left. And I have an open circle at 9, and it's greater than, so I want the bigger ones, right? It's an open circle because I don't have that or equal to, and then it's greater than, so I'm going to draw my arrow to the right. And that'll be a graph that represents our solution set here. Let's try another one. All right, go ahead and try this one. X divided by 7 is less than or equal to negative 2. All right, so this is one when I have to go and solve it. I'm undoing a divide 7, so I'm going to times by 7 to both sides, or multiply 7 undoes divide 7. And when I do that, on the left-hand side, my times 7 and divide 7 cancel, and I'm just left with my x. And on the right-hand side, negative 2 times 7 makes a negative 14. At this point, I can center my graph at negative 14. Since I have that or equal to, it's a closed circle at negative 14. Some numbers that are bigger are negative 13 and negative 12. Some numbers that are smaller are negative 15 and negative 16. And I'm going to draw my arrow toward the numbers that are smaller, like negative 15 and negative 16, because I have that less than or equal to here, right? So the less than means I'm going to the left, and the or equal to right there, that's going to mean the closed filled in circle. All right, that should get us a good start on section 2.3. Calling it 2.3 part 1. Tomorrow we'll go ahead and finish section 2.3 with 2.3 part 2. Hope you have a good day.